at simbolo, tayo ay matuto. Tara na't magsiknayan na tayo.
Good day, students! Welcome to our video lesson in Math 7, Module 18 on writing numbers in scientific notation. At the end of this lesson, you should be able to write numbers in scientific notation and vice versa, and represents real-life situation and solve problems involving real numbers. Answer the pre-test. You may pause the video while answering and play it once you are done. Let us now do the checking. This time, answer the recap. You may again pause the video and play it once you are done. Let's do the checking. In our elementary lesson, we were taught how to read and write numbers in different ways, like standard form, word form, and expanded form. And these numbers are used in the different fields of work like banking, finance, and many more. There are different professions that deal with the use of very small and very large numbers, such as engineers, accountants, chemists, scientists, and many more. Are you ready to learn a new way of writing numbers? Let us take a look at this problem. Do you know that an average human has 25 trillion red blood cells that measures 7810 million meter in diameter, and each cell completes a circulatory lap in about 20 seconds? Can you visualize how many red blood cells a human body have? And how small it is? Let's take a look at these numbers. Did you have difficulty reading the numbers? Is there any other way in writing the numbers wherein we can easily read them? Yes, there is what we call scientific notation. It is a method of writing very large or very small numbers as a power of 10 in a simpler way. It is written in the form of A times 10 raised to n power. Let us now write 25 trillion in scientific notation. First, we have to identify the decimal point. Since there is no decimal point in the given number, it means that it is written on the right side most of the number. Then move the decimal point 13 places to the left so that we will have 2 and 5 tenths. But we have to drop the zeros so that we can be able to write it in the form of A times 10 to the n, which is 2 and 5 tenths times 10 to the 13th power. And the 13 denotes the number of decimal places that the decimal point has been moved. Let us now write 7810 millions in scientific notation. Since in the given number there is the presence of the decimal point, then we can simply move the decimal point 6 places to the right, and we will get 7 and 8 tenths. Then drop the zeros and write the number in the form of A times 10 to the n, which is 7 and 8 tenths times 10 to the negative 6. The exponent negative 6 is from the number of places that the decimal point has been moved. Do you know the size of a coronavirus? Its size is 1 and 2 tenths times 10 to the negative 7 meter. That is really too small that cannot be seen by our naked eye. How do you think is 1 and 2 tenths times 10 to the negative 7 is written in standard notation. Let us write the 1 and 2 tenths times 10 to the negative 7 in standard notation. Since the given number has a negative exponent, it means that the decimal point in the 1 and 2 tenths should be moved 7 places to the left, and then add zeros as placeholders. Then write the number in standard form, which is 1 and 2 tenths times 10 to the negative 7 is equal to 1200 millions. Let us take a look at example 2. Do you know how many droplets are there when you sneeze? Approximately, there are 4 times 10 to the 4th power droplets in just a sneeze. How do we write 4 times 10 to the 4th power in standard form? Write 4 times 10 to the 4th power in standard notation. Since the given number has a positive exponent, it means that we are going to move the decimal point 4 places to the right. So considering the number 4, the decimal point is located on the right sidemost of it. Then move it 4 places to the right. And then add zeros as placeholders. Then write the number in standard form. Therefore, 4 times 10 to the 4th power is equal to 40,000. Now, it's your turn. Write the numbers in scientific notation and vice versa. You may pause the video while answering and play it once you are done. Let us now do the checking. For number 1, we have to move the decimal point 8 places to the left, which is equal to 1 and 24 hundredths times 10 to the 8th power. For number 2, we have to move the decimal point 4 places to the right, which is equal to 3 and 6 tenths times 10 to the negative 4. For number 3, we have to move the decimal point 9 places to the right, which is equal to 7,100,000,000. And for number 4, we are going to move the decimal point 6 places to the left, which is equal to 508 millions. Remember that scientific notation is written in the form of a times 10 to the n power. And to write scientific notation to standard form, move the decimal point to the first factor to the number of places indicated by the exponent of the power of 10. If the exponent is positive, move the decimal point to the right. And if the exponent is negative, move the decimal point to the left. To write decimal number to scientific notation, place the decimal point to the first non-zero digit. Move the decimal point and count the number of moves to be used as the exponent. If the given number is greater than 10, use positive exponent. If the original number is between 0 and 1, use negative exponent. How do we connect our lesson for today in our real-life situation? In this lesson, we encountered very large and very small numbers that can sometimes lead to difficulty in reading and writing. And we learned that there is a simple way to write those kind of numbers. In life, we are given at times big or small opportunities, complicated or simple problems, and many other challenges. Unlike math, facing our real-life problems have no shortcuts. You have to go through the process to learn the lessons in life. Based on experience, how do you handle both your big and small problems? Did you try the shortcut way of solving it? What lessons did you get? Write your answer on a separate sheet of paper. How much have you learned in this lesson? Answer the post-test. You may pause the video while answering and play it once you are done. Let us now do the checking. I hope you did well in this activity. And now, please answer the activities. You may pause the video while answering and play it once you are done. Let us now do the checking. I hope you did well in this activity. And I really do hope that you learned and had fun learning math. Remember, you can always play back this video. Thank you and God bless us all.